Welcome to Study Loop.
All right, guys. To solve this problem, we will first calculate water vapor pressure, that PV1, from the given relative humidity, that is phi 100. Phi 1 is equal to 100%, and the pressure Pg1 at the given temperature, that is T1, is equal to 200 degree Fahrenheit. So we've got PV1 is equal to phi 1 into Pg1 is equal to 1 into 11.538 psi, and that is equal to 11.538 psi. So from the given ambient pressure, that is P1 is equal to 70 psi, and the calculated water pressure, that is PV1, we can calculate the air pressure PA1. So PA1 is equal to P minus PV1 is equal to 70 psi minus 11.538 psi is equal to 58.462 psi. And we will also need absolute humidity, enthalpy, and the specific volume. For the calculation, we will use the given temperature T1 and the pressure PV1 and PA1. We will also need enthalpy for saturated water vapor, that is Hg1, and that is equal to 1145.7 BTU per lbm, and W1 is equal to 0.622 into PV1 divided by P1 minus PV1, and that is equal to 0.622 multiplied by 11.538 divided by 70 minus 11.538 is equal to 0.1228. So H1 is equal to Cp into T1 plus W1 into Hg1, and H1 is equal to 0.240 multiplied by 200 plus 0.1228 multiplied by 1145.7. So the answer is 188.69 BTU per lbm. So guys, moving further, we've got V1 is equal to RA into T1 divided by PA1, and that is equal to 0.3704 multiplied by 660 divided by 58.462, and that is equal to 4.182 cubic feet per lbm. So from the given velocity of air, that is V1, which is equal to 50 feet per second, and the radius of the tube, that is R1, is equal to 0.125 feet, and the specific volume V1, we can calculate the mass flow rate of the air, that is M is equal to capital V over small v1 is equal to V1 into R square into pi divided by specific volume 1. So we've got M is equal to 50 into 0.125 square multiplied by pi divided by 4.182, and The answer is 0.587 kg per minute. So next we need to repeat the calculation for the exit point. For the calculation we will need the relative humidity, that is phi 2 is equal to 100%, and the temperature, that is T2 is equal to 100 degree Fahrenheit. And first we need the vapor pressure, that is PV2, and from it the absolute humidity, that is PV2 is equal to phi 2 multiplied by Pg2 is equal to 1 into 0.95052 is equal to 0.95052, and then we have W2 is equal to 0.622 into PV2 divided by P1 minus PV2 is equal to 0.622 multiplied by 0.95052 divided by 70 minus 0.95052, and that is equal to 0.00856. So next we can use the absolute humidity W2 to calculate the enthalpy H2. So that is H2 is equal to Cp multiplied by T2 plus W2 multiplied by Hg2, that is equal to 0.240 multiplied by 100 plus 0.00856 multiplied by 1104.7, and that is equal to 33.46 BTU per LBM. Now guys, we know that this process is closed system process, and we can use that to calculate the mass flow rate of the condensed water, that is MW is equal to M into W1 minus W2 is equal to 0.587 multiplied by 0.1228 minus 0.00856, and MW is equal to 0.67 0.067, sorry, it's 0.067 lbm per minute. So finally we use the energy balance equation to calculate the heat transfer rate. For the calculation we will also need enthalpy of condensed water, that is HW is equal to 117.99 BTU per LBM, and the mean temperature, that is Tm is equal to 150 degree Fahrenheit. So Q is equal to M into H1 minus H2 minus MW into HW. So guys, we know that 0.587 multiplied by 188.69 minus 33.46 minus 0.067 multiplied by 117.9. So guys, the answer to Q is equal to 83.2 BTU per seconds. So guys, these are the answers to this question. I hope you have easily understood all the calculations and the formulas. Thank you very much.